Welcome back to my channel. In today's video, we're going to be designing YouTube. We're going to be covering the functional and non-functional requirements. And if you've watched this video once or twice, I believe you should be able to design any other system, any other software system in the world with just the idea you're going to be getting from this video. Now let's get into the functional and non-functional requirements without no further ado. Firstly, we are going to be covering the upload functionality. When you upload a video on YouTube, what goes on behind the scene. We're going to be talking about the search functionality. When you search for a video on YouTube, what goes on. We're going to talk about the view functionality too. When you click a video to watch, what really happens behind the scene. We're also going to be talking about how YouTube handles explicit content. Explicit content here could mean many things. It could mean YouTube flags down videos where alcohol or drugs are used, or sexual scenes, they flag it down. It could mean a lot of things, or a video that consists of a lot of swear words or curse words. So our explicit content API is going to flag that down. And last but not the least, we're going to be talking about the recommendation system and how the whole homepage really works. Have you ever noticed that when you watch two videos, let's say you watch two gaming videos, and you go back to your homepage, you start seeing more game videos? So we are going to be talking about talking about that, how it really works and how it can be done. We're also going to be talking about the non-functional requirements, like the scalability of the system. Scalability simply means the ability for our application to accommodate a lot of users and a lot of requests without it crashing or breaking down, or needing the developers or engineers to rewrite the whole system. We're also going to be looking at the resilience of the system. So resilience in software engineering simply means the ability for our app to keep functioning even when one part or more of the application has broken down. So let's say a system like YouTube, let's say you're watching a video and somehow, somewhere, the comments API or endpoint breaks. That shouldn't stop the video from playing or you getting recommendation in the recommendation page. So that's what resilience is about. When one system breaks, it shouldn't stop the other from working perfectly. We are also going to be looking into the cost effectiveness of the system. We're going to be making sure that we're not paying for resources and servers that we are not using. We are only going to be paying for what our application is using. And we're also going to make sure the application is secured from hackers and internet dummies. So we are going to start with the search functionality. When the user search for any word on YouTube, the request hits a load balancer. And if you don't know what a load balancer is, I have a video where I explained what load balancer is and what they do and how they work. You can check that out. So the request hits a load balancer, and the load balancer sends that request to the appropriate search service. So your request goes to the search service server, and the search service server sends your request to our Elasticsearch. And now Elasticsearch, I also have a video where I explain what Elasticsearch is and how they work, but I'm going to give a brief explanation of what Elasticsearches are. So imagine you type funny cats VD on YouTube instead of funny cats videos. So Elasticsearch is intelligent enough to understand that you wanted to write funny cats videos, so it helps you there. And secondly, Elasticsearch is a faster search engine for such applications. Another example is this. Imagine you go on Amazon and you want to buy shoes, and you mistakenly typed SHOW instead of SHOE. Now with Elasticsearch, it's smart enough to understand that what you wanted was shoe, not show. And it also helps us search large amount of data or text really fast. Like, it's extremely fast, trust me. So after our search service API or server sends that request to our Elasticsearch sends back those requested videos back to our search service server, and our search service server gives the customer the video. A quick recap: when you search for a video, the request hits a load balancer. The load balancer is intelligent enough to to know the search service server that has the least request, and it sends your request there. Our search service server sends your request to our Elasticsearch server. Our Elasticsearch server gets all the video for you, all the video you requested for, and it sends back the request to our search service. It sends the request back to our search service server, and our search service server gives you the video and you watch. Now for recommendation system, I never explained this part of it. I wanted us to get how the search functionality works at first. So once your request hits the load balancer sends your and the load balancer sends your request to our search service server. It is synchronously saves that data to our search history database. So once you search for a video, it sends that request to our Elasticsearch server, and it also saves that text to our search history database. After it sends it saves it to our search history database. It uses those data to generate recommendation for you. It's recommendation batch jobs. Just recommend videos for you. Let's say you search for like a gaming video, then it saves that into our search history database and start generating various videos for you in our database. This is an endpoint that generates various videos for you. After it generates, it saves it to our recommendation database. And when you go to the home page, it saves it to our get recommendation database. After it saves it there, and you go back to your home page on YouTube, and you just refresh the home page. Now there's a get recommendation service that fetches all the recommended videos for you from the database. A quick one: once you search for a term on YouTube, it saves that request to our search history database. Now this is our API, get recommendation batch jobs. Our API generates videos for you based on what you have searched for from our search history database. It generates videos for you. After generating videos for you, then it saves. After generating the videos for you, it saves those videos into our get recommendation database. So now when you come and you open your YouTube app or Netflix, any video sharing app, when you open it, something happens, a get request happens. So the get request hits our get recommendation database, and it shows you videos based on what you've been searching previously. If it's gaming, if it's football, you all of a sudden start seeing more football videos. If it's gaming, you start seeing more gaming videos. So that's how the recommendation system works. So this is the upload functionality. Let's say a YouTuber or a creator tries to upload a video on YouTube. The request first of all hits our load balancer. If you don't know what load balancing is or load balancers, please just check on my page. You're gonna see a video where I explain what load balancers are. Our request hits our load balancer first. Our load balancer figures out the appropriate upload service that it should send the request to. After it sends the request to our upload service sends the request to our content ingestion API. Our content ingestion API just takes the video and just it holds it temporarily to check all of these criteria if it matches them. So for example, YouTube don't allow you just upload a video with a very low resolution, like low brightness. So we hold the video temporarily to check all of that criteria before they allow the creator or YouTuber upload that video successfully. So after uploading the video, our content ingestion API uploads the video temporarily for checks. So first of all, we check the quality validation, like the audio level, if the audio of the video is loud enough if it's loud enough for what YouTube had predefined, because YouTube have predefined audio levels for videos. If your video has a lower audio level, it rejects it, and the resolution level too, I just explained that. Then if your video fails any of these processes, and mind you, there are many other processes they check, like for explicit content, for vulgar words, there are many. I just named two. So they check if your audio level is high enough, the resolution is okay. If it passes this, you go to the next stage. If you fail any of this stage, it tells you that, and you go work on your video, and it also check if the video you're uploading does not have virus or any other thing like that. So after your video passes the quality validation engine or API, it transcodes your video into multiple resolution. Imagine when you watch a video when you're watching a YouTube video on your television, you can't compare the brightness of watching it on your TV with when you watch on your phone. So we have multiple resolution of every video you post on YouTube. So YouTube is smart enough to understand where you are watching the video from. If you're watching from your television, it gives you the brightness accordingly. If it's from your laptop, it gives you accordingly, on your phone accordingly. So that we transcode the video into multiple resolutions. This I think is for TV, and this is for laptops, and this is for phones. When you're watching on your phone, this is what you get. So after it transcodes the video into multiple resolutions, it then checks, it then prompts you to enter the title of the video, the duration and description, and also checks, it also verifies that you don't just type any word that they don't want. You don't type any vulgar word. They check that if you type any vulgar word, it returns you an error and tells you why that such words are not allowed on the system. Then after that, finally your video gets saved to the storage, and after it's saved to the storage, the video is distributed into multiple CDNs. So anybody closer to you that wants to watch your video, so the request doesn't go to their own server but the CDN. And if you don't know what CDNs are, please, I have a video where I explained what CDNs are, how they work and everything. First, after it checks that your title, description, after collecting your metadata, it saves it to the system and saves your video to the storage. After saving to your storage, it distributes the video into multiple CDNs. If you don't know what CDNs are, please watch my video. I explain what CDNs are and how they work. After this process is done, then it notifies you, the creator, you uploading the video, that your video has been successfully, uploaded, and it also notify your subscribers. So for the view functionality, let's say a user try to click a video on YouTube. The request first of all hits a load balancer. After hitting a load balancer, the load balancer directs our request to the video watch service. Our video watch service now first of all gets the metadata of the video, like the title, description, and it gets the video playback manifest. Video playback manifest is usually a file that consists of all of the resolution of the particular video you are trying to watch. Let's say you're on your phone, you are trying to watch a MrBeast video. Now the video playback manifest is very intelligent to understand the resolution of your phone, of your device, and it gives you a video with such resolution. If your phone is on dark mode and the brightness is very low, the playback video manifest is intelligent enough to know the resolution of image to give you. Remember, I said YouTube breaks down our videos into multiple resolution. So this video playback manifest now is intelligent to understand your device resolution, and it gives you a video accordingly. So after that is done, the request then goes to our CDN to check for the video, to give you our CDN, a nearby CDN around you. If you don't know what CDNs are, please, I have a video where I explain what CDNs are and how they work, everything. You're going to understand it and love it. So the request then goes to our CDN to check if the video is there. If the video is in a nearby CDN around you, it returns the video to you in chunks. So the more you watch, the more the chunk, the buffering increases, the chunks increases. So it returns the video to you. Then you start streaming the video on your device. Now if the video is not saved on our CDN, it pulls the video from AWS S3 or Blob or any other video storage platform for you. It pulls it from AWS S3. Then you start streaming the video, you start watching the video. Then after it pulls from AWS S3, it puts the video back to the nearest CDN around you. So if you want to watch that video again, it doesn't go back. If you want to watch the video again, it doesn't go back and pull from AWS S3 buckets, because anytime you pull a resource from AWS S3, it's money. Your money is going. So once you pull from AWS S3 bucket or blob, you put that video in a nearby CDN around that customer. So when the customer is coming again to watch the same video, we just go to our CDN and return the video to them. It doesn't hit our S3 bucket or blob anymore. So after pulling from AWS S3 bucket, you start to stream the video, obviously. Then when you are streaming the video, something is happening behind the scene that you are not seeing. Your view, the view history database, something has been updated there. Let's say you're watching a football video, right? It's a 20-minute long video, and you watch that video till the 18th minute. So that tells us that you actually like football. So it saves the amount of time you watch that particular video. So it starts to understand what kind of videos you like. So because of that, it starts generating such videos for you. When you go to the home page, you start seeing similar videos. You start seeing more football videos. And if it's a wrestling video you are watching, it checks the amount of time, how long the video is, and how long you actually watched it. So after seeing that, it now starts generating similar videos for you. If you watch 3 football videos, and if you watch 3 football videos 20 minutes long, you watch like 18 or 17 minutes, the system understands now that you love football. And let's say you watch a wrestling video, just a wrestling video that's 10 minutes long, and you watch for 2 minutes. So now it gives you more football videos, and it also gives you wrestling video, but lesser than the football videos. So that's how the recommendation actually work. And also for analytical systems, when you go to your settings on YouTube and you try to watch how long you spent on a particular video and everything, just for analysis. I'm going to give a quick recap. After you get the video playback manifest, the right video for the current device you are using. After it understands that, it checks our CDN it checks the nearest CDN around you if the video is already there. If the video is already there, it gives you the video. After it gives you the video, and you start streaming, and our async login starts working, start checking the amount of time you are spending on it. And if the video is not in a nearby CDN around you, it pulls the video from AWS S3 or Blob or any other video storage platform you use. So after that, you start streaming the video, and it saves that video immediately to CDN. Because anytime you are pulling something from AWS S3, your money is going. So you need to be smart enough to know what to do, what little tricks you to do to prevent your money from going unnecessarily. So yeah, it distributes to CDN. So the next time you are coming to watch that particular video, it's no longer pulling the video from AWS S3. It's now Blob. Or if anyone around you wants to watch that particular video, it fetches that video from our CDN. Then you start streaming your video, and our async login, everything starts working. So I think we've come to the end of this video, and please, I put in a lot of time and effort into creating this video. Please help me like, subscribe, share, and comment down what sort of system design concept you want me to cover, or what platform, any software platform you want me to define and explain the system design like this, and I'll gladly do it. Thank you.